Hey there. So if you've ever dipped your toes into C programming, you've absolutely run into Printf. And yeah, on the surface, it just prints stuff. Simple, right? Well, today we're going to pull back the curtain and show you why this one function is actually a genius lesson in how computers really think about data. To really get why Printf is so cool, you gotta look at what came before. Just imagine needing a totally separate function for every single thing you want to print. Print int for integers, print char for characters, print string for strings. What a headache. It was a lot to keep track of. C just swept all that complexity away and gave us one super elegant do-it-all function. So how in the world does it pull this off? How does one function do the job of like 5 or 6 others? Well, it's not magic, but it's pretty darn clever. The secret is all in how it's designed. Okay, so here's the secret sauce. The very first thing you give Printf is a string, and you can think of it like a template. See those percent signs in there? Those are the magic placeholders. For every placeholder you have, Printf expects another piece of data, another argument right after the string. It just goes down the line, one by one, and slots them in. And check this out. We're using the same numapples variable twice, but as you're about to see, Printf can show that single value in 2 totally different ways. Yeah, that percent sign, that's the big signal flare. When Printf is reading through your string, the second it sees that percent, it hits the brakes and says, whoa, okay, timeout. I need to grab the next variable from the list and stick its value right here. It's literally the thing that turns a boring, static sentence into something dynamic and useful. But just swapping in a value, that's only half the story. The real power, the secret key that unlocks everything, is the character that comes right after that percent sign. And that little thing is called a format specifier. Now, I want you to burn this word into your brain, interpreted. That's the key. A format specifier doesn't just blindly print a value. No, it's a set of instructions. It tells the computer how to understand the raw, jumbled bits of that value, and then how to turn it into something human-readable on your screen. Which leads me to a little pop quiz. Let me ask you, what is the value 97? I mean, really, is it just the number 97? Is it a letter, a symbol? What is it, fundamentally? And here's the answer. It depends entirely on how you ask. Check this out. If you tell Printf to treat 97 as a decimal integer, using %d, it prints the number 97. Makes sense. But if you use %c and tell it to treat that exact same number as an ASCII character, you get the letter A. The underlying data, the bits, never changed. Only our interpretation did. And that's it. That's the whole game right there. The data is just data. It's meaningless until you tell the computer how to look at it. All right, so now that we get the why, let's build up our practical toolkit. To really get good with Printf, you've got to know the most common specifiers like the back of your hand. So for integers, you've got a few main options. %d is your everyday workhorse, your default for regular signed numbers, positive or negative. Then there's %u for unsigned numbers, when you know for a fact your value can't be negative. And then there's %x, which is a lifesaver for debugging. It shows you the number in hexadecimal, which is way closer to how the computer actually sees it in memory. Okay, moving beyond numbers, there are 3 other essentials you absolutely need to know. We've already met %c, that's for a single character. Next up is %s for printing out a whole string of text. Oh, and a super important security tip here, always use %s to print a string. Never, ever just pass your string variable as the first argument to Printf. That can lead to serious problems. And finally, there's %p, which is your best friend when you're working with pointers, because it prints out raw memory addresses. All right, now here's the thing about C. It's a language that is very particular about the size of your data. How many bits an integer takes up, whether it's 8 bits, 16, 32, or 64. And of course, Printf has a way to deal with that level of detail. These are called length sub-specifiers. Just think of them as little prefixes that you stick right between the percent sign and the main specifier letter. So, for instance, if you want to print a big 64-bit long integer, you can't just use %d. You have to use %ld. That L tells Printf exactly how many bytes to look for, which helps you squash weird bugs and make sure your output is always right. Okay, so we've got the basics down. We know how to tell Printf what kind of data we have. But what about making it look nice? Well, this is where Printf really starts to show off. It gives you an amazing amount of control over the style and formatting of your output. Let's check it out. Whoa, okay, I know this looks a little scary, but don't panic. This is just the full, formal structure of a format specifier. All those bits in the middle, the flags, width, and precision, they're all optional. You just add them between the percent sign and the final letter to get more control. We're just going to break down a couple of the most useful ones. First up, let's talk about width and alignment. So if you write something like printf %5d, that number 5 tells printf, hey, make sure this output takes up at least 5 character spaces. By default, it'll pad with spaces on the left to right align it. But if you just toss in a little minus sign flag right after the percent, like %-5d, it completely flips it. Now it's left justified. This is amazing for making nice, neat columns of text. But what if you don't want to pad with empty spaces? What if you want to use zeros instead? Easy. Just use the 0 flag. By putting a 0 right before the width number, you're telling printf to fill that extra space with leading zeros. This is super useful for things like formatting file numbers or time, where you always want a consistent length, like 007. Okay, one last styling trick, and this one is specifically for strings. That little period, the one that introduces the precision part, it does something really cool when you're using %s. So in this example, we're saying, yeah, print this string, but that .5 is a rule. It tells printf, I don't care how long the string is, you are only allowed to print a maximum of the first 5 characters. And as you can see, the result is that the string gets cut short. It's a really clean and simple way to make sure your text never gets too long and messes up a nice, tidy layout. So after all that, what's the big idea? The point is that printf isn't just a tool for printing stuff to the screen. It's really more like a teacher. Every single time you use it, it forces you to stop and think about what your data actually is. You have to make a choice. Are these bits I'm holding a number, a character, a memory location? It's this constant hands-on lesson that deep down, in the guts of the computer, it all comes down to interpretation. And that kind of leaves us with one final question to chew on. This whole idea of having to explicitly tell a function how to interpret a chunk of raw memory, it's not just a printf thing, it's a fundamental concept in programming. So, as you go forward and write more code, keep an eye out for it. Where else do you see this pattern? What other functions or tools make you, the programmer, be the one to decide what all those ones and zeros actually mean?